Hello. For those of you who've been watching my channel for some time know that a few years back I wrote my own app which I used to overlay computed positions of the sun, the moon, and the stars on top of my cameras that I set up back in 2019. Here's a playlist for the full history of that. As a result of doing what I wanted to do for that project was to calculate the position of the various objects using first principles. To do that, I ended up looking online for various formulas and algorithms. I certainly was not going to derive them myself. That's just a little bit over my head. However, I was able to find various formulas, and with those formulas, I was able to either port them over to Java, or I was able to create my own code from various equations, such as the direction and the position of the sun from the NOAA solar spreadsheet calculator, which I have talked about on many occasions. So the long and the short of it is that I know exactly where the formulas that I use came from because I did that myself. And as a result, by comparing how my application generates the image and how it compares with other tools, I can gauge whether or not I'm in agreement with those other tools, and it gives further legitimacy of those tools when compared against real-world examples. I wanted to make this video before the final experiment happens and before the people who are going to Antarctica go down, so that I could put on official record on YouTube, for example, what people are going to see when they go to a certain location. One of the experiments MC Toon wants to make is to record the star trails in Punta Arenas when he goes down before they go to Antarctica. He might also do it again whenever he comes back and before he goes home. That's going to be something that he's going to have to decide for himself. The whole issue arises from the fact that flat earthers don't really have a model, and they just make certain assumptions. They cannot and will not explain how there are two points of rotation on Earth, one of them being Polaris and the other being the opposite of Polaris, or in other words, that there is a northern celestial rotation and a southern celestial rotation. These are very easily observable facts, and that is one of the experiments that MC Toon is hoping to accomplish while he's down there. Having coded all of the formulas myself and using those formulas, I can say with 100% certainty that the formulas indicate that there will be two points of rotation, one of them being the south celestial pole. So my first generation skywatching app, which turned out to be a bit of a sandbox and not very well coded because I wasn't really sure what I wanted to build when I was building it, should be good enough to do the job. So I have made a number of animations which I will play in this video. One of them will show that indeed there is a southern celestial pole when facing south. East is over here, you can see west is over here, and as I rotate you can see that the sun is going down in this direction, and it will set when it reaches right around there somewhere. So in fact the sun should be setting south of due west. From various time lapses of the north celestial pole that I've done in the past, I would suspect that MC Toon should start to see stars. I would suspect probably somewhere around here. He may possibly see a few of the brighter stars, maybe somewhere around here. And if you look at the sky in this app, I tried to simulate more or less what a camera would see when trying to properly expose for the stars. I do believe that the best the sun will do is about 13.65 degrees below horizontal, roughly, or more or less around that, which means that in order to see no light pollution of any kind, MC Toon would have to be out in the middle of the woods somewhere with no ambient street lights, and it would have to be after astronomical twilight, which will not happen in that location at this time. If he plans on staying up all night, he probably won't get much past this point before the light in the sky starts to block out some of the dimmer stars. Second animation is where I lock the azimuth of the camera, the quote-unquote camera, to the position of the sun. And so while the sun may appear to remain in the middle, you'll see that the compass direction markers will change throughout the day and throughout the night. So here, this is local noon. About here, the sun should be due west, and so on. I wanted to make these animations using the software I wrote, using the equations I found online, and trying to build this app up from first principles. So how does that compare with something like Stellarium? Not exactly sure what day MC Toon is going to land there, but if he gets there on the 12th, here Stellarium is saying that the sun should set right around here, which is going to be about halfway more or less between west and south. And just like my app, there is a southern celestial pole, and the sun is going to rise somewhere between east and south. And if we decide to try to look through the ground, you can see Polaris is right here, which is very similar to mine. And just like Stellarium, when MC Toon gets to Punta Arenas, if he could look through the ground, he should see Polaris. And for bonus footage, I'm also going to play a video clip that I recorded on my tablet from an app that I got on it called Skywalk. That's going to be it for now. Thank you for watching. And if you like the video, thumbs up, yada, yada, yada. You know what to do. And with that, I'm going to see you again in another video soon enough. So bye for now.